Okay, good morning, students. Can you hear me? Can you all hear me? Yes. Please unmute your please mute your microphones. So don't speak to mic. If you have any doubts, you can put your doubts in the chat box. Huh? Right. Okay. Then take the tutorial and let's go for the discussion of past MCQ from unit number 1, atomic structure. So in the first question, the question type they have given atomic theory of matter, atomic nucleus, atomic number, mass number, and isotopes. So under these topics, let's see what are the questions that they have given in past exams, and let's quickly discuss these questions. Right. Number one, nucleus charge of oxygen is, right. Look at the first question that they have given. Nucleus charge of oxygen. Students, you know that when we consider the oxygen atom, the atomic number is actually 8. Right? So mass number of oxygen atom is 60. So when you count the number of electrons in the oxygen atom, that is 8, number of protons 8, and number of neutrons also 8. So nucleus charge means we know that atomic nucleus is containing protons and neutrons. And neutrons are neutral. So therefore neutrons are not contributing for the charge of the nucleus. Remember that they are asking the charge of the nucleus, not the charge of atom. Charge of the atom is already neutral. So therefore, they're asking only about the atomic nucleus. So we don't have to worry about the electrons. Then we have to worry about the protons and the neutrons. And as we discussed, neutrons are also not contributing. So therefore, the number of protons, only the effective factor for the charge of nucleus. So then we can tell that we have learned that the charge of a proton, right? Charge of a proton is 1.602 10 to the power minus 19 coulomb. So then tell me, what is the charge of nucleus? So the charge of oxygen atom nucleus, we can tell that 1.602 10 to the power minus 19 coulomb into 8. So when you multiply this one by 8, what is the answer? 16 here, 48, 4 here. So 12.816 10 to the power minus 19 coulomb. If not, we can tell that 1.2816 10 to the power minus 19 coulomb. So this is the charge of oxygen atom nucleus. So have they given this kind of answer? No. Second one is actually value wise, that's okay, but look at the way that they have given the decimal values. 128.16 10 to the power minus 22 coulombs. If they have given this one in 128 value, 128.16, then the 10 to the power value should be 10 to the power minus 20. So therefore, students, this answer is wrong. So question number 1, we are not given the correct answer. Therefore, none of the above. They have given option like none of the above. First question, answer is number 5. Question number 2. The scientists who work hard to put forward an atomic nucleus model, they have given 5 answers. Thomson, Marsden, Millikan, Becquerel, and Einstein. So let's see what are the contribution for the development of atomic theories, atomic models, or related to the first unit. What are the contribution from these scientists? We have learned about Thomson. Thomson is the one who found the electron, and we know that plum pudding model of the atom is actually discovered by Thomson. So therefore, atomic nucleus, he doesn't have any contribution for the atomic nucleus. What about Marsden? Yeah, Marsden has actually contribution, right? Because we have learned that under the gold foil experiment, Ernest Rutherford found the atomic nucleus concept. And there actually I told you that there were two students of Rutherford who helped to do this experiment, right? Who are they? Geiger and Marsden. So therefore, this is one of them. We can consider Marsden is actually one of the correct answers for this one. Millikan, no. We know that Robert Millikan is the scientist who found the charge of an electron by doing the oil drop experiment. So therefore, we can't consider the third one, Millikan. Fourth one, Becquerel. Becquerel is actually found the radioactivity. So therefore, no contribution. Einstein, no. Einstein is actually not contribution for the There is no contribution from Einstein for the development of atomic nucleus. So therefore, easily you can go for the answer. Question number 2, answer is second one. Mass then. Question number 3. The radius of an atom is in the order of, remember students, we have discussed under the Rutherford's atomic theory. I told you that in the Rutherford's atomic model, the atomic radius, right? And then we can tell that the nucleus radius is about, we can consider that atomic radius is about 10 to the power minus 8 centimeters. And the nucleus radius is about 10 to the power minus 13 centimeters, right? So normally this is the range that we can consider the atomic radius existing and the nucleus radius is existing. So therefore, the radius of an atom is in the order of 10 to the power minus 8 centimeters. Question number 3, answer is. Question number 4 is related to the atomic nucleus radius, right? The atomic nucleus radius approximately is 10 to the power minus 8, 4, minus 10, minus 12, minus 5. Actually, we don't have the correct answer. The correct answer should be 10 to the minus 13. But since they have given approximately, we can go for the nearest value, 10 to the power minus 12, right? So therefore, question number 4 is also answer number 4. Right? These things are very easy. Let's quickly finish these things. Question number 5. Question number 5 is actually statement type of a question, right? So first of all, I will remind you how to answer for the statement type of questions. I have explained this one you, but anyway, you have to learn how to choose the correct options when you are given 4 statements. Normally in the A-level examination paper, students, question number 31 to 40, you will be given 4 statements A, B, C, D. Then you have to check whether these statements are correct or incorrect. If you get that A and B statements correct, right? If A and B correct, we can tell that the answer is number 1. That means you have to choose the option number 1. If B and C statement correct, we have to get the answer as number 2. If C and D correct, we can take that the answer is number 3. And if A and D is correct, we can get the answer as number 4. For any other option, right? Any other option. What are the any other options? We can consider that only one statement is correct. We can say that all the statements are correct. All the statements are wrong. Then A and C is correct, B and D correct. So likewise, any other option, answer is number 5. So keep that in your mind when you're answering for the questions like these kind of statements A, B, C, D. This is the way that we have to choose the options among 5 they have given, right? Okay. Now let's go for the question. A sample of chlorine has a mixture of isotope with both mass numbers 35 and 37. The atomic number is 17 and the relative atomic mass of chlorine is 35.5. The conclusion or conclusions can be made by using the data given above is R, right? Look at this one. They have given, we have discussed about the isotopes. Remember students, chlorine is forming 2 types of isotopes mainly. The first one is actually chlorine 1735 and the other one is chlorine 1737. These are the 2 types formed by chlorine. They have given that average relative atomic mass. They haven't given average relative atomic mass, just relative atomic mass. But you have to know that we have done the calculation in the theory class also. Average relative atomic mass. Average relative atomic mass of chlorine is 35.5. Then let's go for the statements they have given. Chlorine 35 is radioactive. No, we didn't learn something like that. That is incorrect. Natural sample of chlorine contains more chlorine 35 than 37. Yes, students, this is actually depending on the relative abundance. Relative abundance means how much that isotope is existing in the nature as a percentage value. For example, I can say that I'm telling you the not correct values. For instance, if I consider this is 80%, right? Chlorine 1735 is 80% and this is 20%. Then the average relative atomic mass is very close to this highest relative abundance isotope value. So this is 35. So you can see that average relative atomic mass is 35.5. Then you can tell that which isotope is more abundant in the atmosphere or in the nature. We can say that since this value is very close to 35, so we can tell that this isotope is the most abundant isotope, chlorine 1735 than chlorine 1737. So natural sample of chlorine contains more chlorine 35 than chlorine 37. That's correct. Both isotopes have the same electronic arrangement. Yeah, right? Because these are same element, chlorine, chlorine. Electron configuration is same. Atoms with mass numbers 35 and 37 respectively have 17 and 19 neutrons in each. What do you think? Atoms with mass numbers 35 and 37 respectively have 17 and 19 neutrons. When you consider this one, how many neutrons are there? We know that mass number is representing number of protons plus neutrons plus. By looking at the atomic number, you can say that number of protons in this isotope is 17. So then we can say that number of neutrons are here 18. Now look at this one. Here you can see that number of protons in here chlorine is 17. So when you take the difference of this one, answer will be 20. So therefore, this statement simple D is wrong. Then tell me, in question number 5, B and C statements correct. Therefore, answer is number 2. Right? Since B and C statement correct, we can choose the answer number. This is the way that we have to choose the answers. Huh? Right. Now let's go for the question number 6. The gold leaf experiment done by Rutherford using alpha particles explains that the atom consists of electrons. No, Rutherford didn't talk anything about the electrons, so we can't tell like that. The mass of atom is concentrated into a point and the volume of it is very small. Is that correct? Yes, that's what we learned. In the Rutherford's model, students, we know that the main idea is about the atomic nucleus. And you remember in the Rutherford gold foil experiment, some of the alpha particles are going through that gold foil and some of them are actually deflecting, right? They are deflecting with huge angles. Some of the alpha rays are deflecting with small angles because of the existence of the atomic nucleus. Because alpha particles are positively charged, when they meet atomic nucleus, positive, they will repel. That's why alpha particles are deflecting with large angles or in small angles. So therefore, we can say that simply the Rutherford's atomic model, the nucleus model, sometimes it is known as the nucleus model, because the main idea that they have given in the Rutherford model is what? Atomic nucleus, right? So therefore, that statement is, yeah, that's correct. Atom are building units of matter. No, Rutherford didn't tell like that, right? Who said that one? Who said that one? We have learned about John Dalton, right? So he said that the fundamental is actually atom in the matter. Neutrons are found in atoms. No, neutrons are actually found by James Chadwick. So therefore, we can't accept that statement also. So in here, only B statement correct. If one statement correct, then we have to go for any other option. Question number 6, answer is number 5. Because students, the only correct statement here is B. Therefore, we have to go for the option number 5. Now let's go for the question number 7. The false statement regarding the following statement is A. Every atom in an element has an equal number of electrons in each of them. Is that correct? Every atom in an element has an equal number of electrons in each of them. Yeah, that's correct. Even though when we consider the isotopes, number of electrons are same, right? When you consider the 3 isotopes of hydrogen, deuterium, tritium, and the protium, so their electrons are same, right? So the only changing fact is, can you remember hydrogen 1, 2, and hydrogen 1, 3? If you consider the electrons 1, 1, 1, protons 1, 1, 1. So the only change is neutron, 0, 1. So therefore the electrons are same. When you consider a particular element, always the electrons are same. Atoms, okay, we are considering the atom. Every atom in an element has an equal number of neutrons. That is wrong, students, right? Because if there are existing isotopes, we can say that the number of neutron count is changing. Therefore, we cannot say that every atom in an element has the same number of neutrons. That is wrong, right? That's wrong. So therefore, the answer can be the second one. Let's see. Every atom in an element has an equal number of protons. Yeah, that is also correct, right? By forming the isotopes, number of proton count and the number of electron count won't change. So therefore, we can say that we have the same number of protons, right? So that is also fine. Every atom in an element has equal number of nucleons. Remember, students, here we have to consider that nucleons means number of neutrons plus protons. So we know that number of neutrons are changing by the time when you consider the isotopes. So therefore the nucleons also change. So therefore the statement that they have given, every atom in an element has the equal number of nucleus, wrong, right? In an atom, the atomic number is equal to the number of electrons it has in an atom. Yeah, when you consider ions, that is wrong, because when they are forming ions, they either get electrons, gain electrons, or removing electrons. So therefore, in ions, this statement is wrong, because when you consider sodium and sodium plus the same element, but they are in two different forms. This is an atom, this is an ion. Number of electrons here 10, 11, and here we can say 10. So, but look at this one, in an element, the atomic number is equal to the number of electron it has in an atom. Yeah, when you consider an atom, that is correct. Okay, so therefore 5 is also correct. But did you see that we have two answers, second one and fourth one? Yeah, sometimes in the examination you might have these kind of questions which are having two answers, three options. Sometimes if you are not given the correct answer in that paper, you will be given free mark for that one. So that kind of a question is known as all, right? All, that means we don't have any answer for that question. So that is actually error from their side, right? The one who make the paper. So therefore, you will be given free mark for that kind of a question, right? Okay, let's move for the next question. So these questions are very easy, students, right? So the main reason I thought to discuss this past paper question is, first of all, students, now we completed the first unit, right? After the completion of unit, definitely you have to do the past papers, right? So we can't limit this one only for the first unit. Soon after the second unit, third unit completion, you should be able to complete the all past paper questions, at least from 2010-11, all the 10, you can start from at least 2014, last 10 years. So you can choose them and you have to do the past paper MCQs, essays, structured essay. From atomic structure, normally they are giving one MCQ. Rarely they are giving structured essays, small questions. So therefore we can say that what? We can say that you have to do the past papers completely after the completion of unit. Okay. Right. Okay. Question number 8. The atom was first articulated to the world by whom? Cannizzaro, Dalton, Debaunier, Avogadro, Mendeleev. Who is that? Dalton. So therefore, question number 8 answers number. So they have given very small, very easy questions in the examination. Question number 9. Rutherford's Goldfoil experiment revealed that, again statement type of a question, quite a large space of matter is empty. Yes, that is the first conclusion he made by this experiment. The positive charge is concentrated as nucleus. Correct. Nuclear concept. Only a thin layer can radiate the particles. No, we didn't discuss that type of thing. The electrons move in quantized energy levels. No, quantization and everything we learned that one in Bohr's energy model and quantization theory represented by Max Planck. So therefore, C and D statements are not related to this one, but A and B correct. Question number 9, answer is first one. Okay, because A and B statements are correct. Now let's move for the next one. The mass of an electron is. So they have given 5 options, students. When you analyze these values, first of all, tell me what is the mass of an electron? What is the value we learn? Mass of an electron. I believe that you can remember the values we learned, 9.107, 10 to the power minus 31 kilograms. Then when we consider the mass of proton, 1.672, 27, no? 10 to the power minus 27 kilogram. And then mass of neutron, this is 5, 10 to the power minus 27 kilograms. So in this way, we can say that the mass of electron, proton, and neutron. So therefore, when you consider the mass of electron, what is the mass of electron in grams? 9.107, 10 to the power minus. In order to convert kilograms into grams, we know that we have to multiply that one by 10 to the power 3. So therefore, minus 28 grams. So therefore, they have given the correct option here. Question number 10 answer is number 10 answer is third one. Okay. This is 7.5 and this is 7.2. Okay. Mass of a proton is 1.672, 10 to the power minus 27. And mass of a neutron is 1.675, 10 to the power minus 27. Keep that in your mind. Okay. Question number 10 answer is third one. Now let's go for the question number 11. In the question number 11, there is a small typing error also. Let's see. The true statement regarding a particle. Now, simply, alpha particles take up electrons to make helium molecules. Is that correct? Yeah, alpha particles are actually taking electrons. We know that, students, alpha particle means, what is exactly an alpha particle? Alpha particles means we can say that helium nucleus. Helium nucleus. Helium nucleus means we can say that is alpha helium 242 plus. In this way, this is the notation of alpha particle. If not, we can tell that alpha 2. So now you can say that in this way, alpha particles take up electrons to make helium molecules. Yeah, that's correct, because it can take another 2 electrons again in order to form helium. The penetration power of alpha particle is very small. Remember, students, you have to know that one. I gave you this one as a question in the theory class to do that one as a homework. We know that we have discussed about alpha particle, beta particles, and gamma particles. Alpha, beta, and gamma, right? So when you consider this alpha, beta, gamma, remember always the penetrating power. Penetrating power is increasing for this direction, right? We can say that penetration power is greatest in gamma particles. So when you consider ionizing power is greatest in alpha particles, right? Ionizing power is greatest in alpha particles. So this is what you have to remember. When we consider the penetrating power, alpha particles actually can be stopped by a piece of paper. Beta particles will go through the thin foils, right? And gamma particles actually can be stopped by a kind of a lead container. So therefore, they can easily go through, they can easily penetrate through solid compounds. Ionizing power, when we consider ionizing power greatest in alpha particles than beta particles, then the least one belongs to gamma. Okay. Then according to that one, we can tell that B statement, the penetrating power of alpha particles is very small. That's correct. C statement, the ionization power of alpha particles. Okay, correct that one. Alpha particles is very small. That is wrong, right? Ionization power is actually greatest in alpha particles. alpha particles move towards n pole in a magnetic field. That means I told you that when we discuss about the cathode ray experiment, in an electric field or in a magnetic field, normally electrons and the alpha particles actually deviate, but gamma particles are not deviating. The reason is gamma particles are not deflecting towards any of these poles, or in electric field, positive pole or negative pole. The reason is that is neutral. And one more thing I told you, that specifically in magnetic field, we cannot say that electrons are deflecting towards the negative pole or positive south pole or north pole, right? So you have to remember that one. So therefore this statement is wrong. C and D statements are wrong. A and B correct. Question number 11, answer is first one. Question number 11, answer is first one. Right. Let's finish this one quickly. Very easy. Question number 12 is, students, actually the new standard used to express the relative atomic mass. They have given actually here none of the above. This question is actually not related to our current syllabus. So therefore 1989. So therefore we can just ignore that question. So let's move for the question number 13. Now. So question number 12, just ignore it. Let's consider these are actually all syllabus theories. So therefore we don't have to worry about that. Okay. Question number 13. The quantity of the electronic charge was experimentally shown by who? We know that is Robert Millikan, right? So what is the charge of an electron? Just now we discussed in the first question, 1.602 10 to the power minus 19 coulomb, found by Robert Millikan, and the experiment is oil drop experiment. So don't forget these things. These things are very important. Okay. Oil drop experiment. Then, so the answer for the question number 13 is number 2. Very easy. Question number 14. The penetration power of alpha particles is greater than the beta particles. Just now we discussed that one. When you consider the penetration power, definitely beta particles has the greatest value. So therefore here they have given the penetration power of alpha particles is greater than that of beta particles. And one more thing, students, as we discuss, I told you that question number 31 to 14, the examination, you will be given statement type of questions, A, B, C, D. Last 10 question, that means question number 41 to 50. Last 10 question number 41 to 50. So you will be given there 2 statements, right? In 2 boxes, right? They will give you 2 statements like this. So here also we have 5 options, right? Let me take the first one, second one, third one, fourth one, and the fifth one. This is the way that we have to choose the answer when you are given 2 statements like this. The first thing is actually, the first statement is true, right? And the second statement is also true, right? Remember, if you want to choose the answer number 1, second statement should explaining the first one, right? We can say that second one is explaining first one, first statement, right? Second statement is explaining the first statement. Then only we have to choose the option number 1. If you consider just they are true, and the second statement is not explaining the first one, we have to choose the answer number 2. What about answer number 3? First statement is true, second statement is false. Then you have to choose the answer number 3. First statement is false and the second statement is true. Then you have to choose answer number 4. If both the statements are wrong, you have to choose answer number 5. This is the way that we are choosing answers for the question number 41 to 50 in the examination, right? First statement is true, second statement is also true, and second statement is clearly explaining the first statement, then choose the answer number 1. If the second statement is not explaining the first one, but both the statements are correct, then answer number 2. True, false, 3, false, true, false. Fine. Remember that one, okay? In the tutorial front page, in the first page, actually, I have given you the instruction. Before you go for the questions, actually, read the question instructions, okay? Right, now according to that one, you can see that they have given two statements. The penetrating power of alpha particles is greater than beta particles. Students, that is wrong, right? Just now we discussed the mass of the alpha particles is very much greater than the mass of beta particles. Is that correct? Yeah, that's correct. When you consider alpha particles, we know that alpha 2 4, beta is actually beta minus 1 0. So this is actually just an electron. When you consider the electron, mass of electron, alpha particle is containing, alpha particle actually doesn't contain any electrons because two electrons are removed from the helium nucleus, helium atom. Then we have only the helium nucleus. That means two protons and two neutrons. So therefore, definitely we know that alpha particles has the greatest radius, greatest mass. Why? Proton neutron mass is actually greater than electron mass. So the electron mass is negligible compared to the proton mass and neutron mass. So therefore, that statement is correct. First statement is wrong. Second statement is correct. Then what is the correct option for the question number 14? Answer is number 4. Okay. So question number 14, we can say that answer is number 4. Question number 15. The charge to mass ratio of the electron was experimentally determined accurately by Crookes, Millikan, Geiger, and Marsden, Thomson, Chadwick, who found the E of M ratio, right? We learned that two quantitative experiments conducted by, one is by Thomson and the other one is by Robert Millikan. Robert Millikan found the charge of an electron 1.60 to 10 to the power minus 19 coulomb using the oil drop experiment. When you consider the E over M ratio value, E over M ratio value found by J. Thomson, 1.759 10 to the power minus 11 coulombs per kilogram. Right, using this one only we can find out the mass of electron because charge of that electron is given by Millikan. When you know the charge, we can find out the mass of electron. So therefore, this is found by JJT. So therefore, that statement in the correct answer for this one is Thomson. Question number 15, answer is number 4. Students, these are completely direct theories we learn in the theory class. Question number 16. We don't have to waste time here. Let's quickly discuss these questions, okay? The isotopes of a given element have the same number of neutrons. Remember, that is wrong, right? Neutrons are changing. That's why isotopes are existing. So therefore, that is wrong. Have the same number of protons. Is that correct? Yeah. In isotopes, we have always same number of protons, same number of electrons. They are not changing. Have the same number of electrons? Correct. Have the same number of nucleons. Is that correct? Since the number of neutrons are changing, we can't accept that one. B and C statements are correct. Question number 16, answer is second one. Go for the next page, page number 4. This one should be 10 to the power plus 11, no? So this one should be 10 to the power plus 11, okay? Plus 11, not minus. Right. Let's move for the question number 17. Which of the following statement concerning the beam of electrons is true? What is the correct one? It is attracted towards the cathode. That is wrong, because we know that electrons are actually negatively charged. How they can attract to the cathodes? That's wrong. Uh, it is attracted towards the N magnetic pole. Again, wrong. It is attracted towards S magnetic pole. That is also wrong. It is deflected away from the anode. Wrong. Actually, it is actually going towards the anode. All of the above statements are false. Yeah, that is the correct option. Question number 17. Answer is number 5. Question number 17. Answer is number 5. Next one. The E over M value for the electron was experimentally determined. Just now we discussed. They have given options like this: Millikan, Crookes, Rutherford, Marsden, none of the above. Thomson is not given, so therefore the correct answer is what? None of the above. Question number 18, answer is number. Question number 19. Look at this one. So this is a calculation, okay? Naturally occurring carbon contains 98.89% of carbon-612 isotopes and 1.11% of carbon-613 isotopes. The relative atomic mass of carbon-613 is 13.033. The relative atomic mass of naturally occurring carbon is. Look at this one, will you? First, they have given there are two isotopes of carbon, carbon-612, and the other one is carbon-613. And the relative abundance value they have given for the carbon-612 is 98.89%. And the relative abundance value for this one is 1.11. Then we know how to calculate the average relative atomic mass. When you are given two types of isotopes, you can easily count that one. Average relative atomic mass, this is equal to, we know that mass number here 12, 98.89 plus what is the mass number of the second isotope 13. Percentage is actually 1.1. So this is divided by 100. When you do the simplification, students, you will get the answer for this one as 12.011. So this is the average relative atomic mass of carbon. Question number 19, answer should be 4th. Question number 19, answer should be 4th. Okay. Shall we move to the next one? Right. Question number 20 also, actually, I can consider that one as very, since it is very old syllabus. We don't know that theory. We didn't learn that theory, but I will tell you the answer. Okay. You can search that one. The confusion that existed among chemists at the earliest stages of the study of chemistry regarding the concept of atomic weight was dispelled by, okay, Dalton, Avogadro, Cannizzaro, Moseley, and Rutherford. Actually, the answer should be Cannizzaro. Okay, so that is the answer. But remember, actually, we don't know. We didn't learn any name like that. So therefore, we can consider this question is 20th one is also all syllabus. But I will give you the answer for this one. Anyway, answer is third one. No? Answer is third one. Right? Cannizzaro. Right? Question number 21. Question number 21. The atomic, this is actually 1996 A level, okay? Then you can imagine how old is that. Question number 21. When you are doing very old past paper, students, be careful. Some of the things are there actually we didn't learn, and you don't have to try those kind of questions. What are the questions you can try in very old past papers? You can try them. Others, just leave it and go for the next question. That's the way, okay? So I'm recommending you to do the past papers. If you are doing past papers continuously, better you choose after 2011. That's good, okay? Because after 2011, most of the question types and everything are related to our new syllabus, right? So the new syllabus paper is actually started from 2019. So we have only 5 papers then. But 2011, after 2011 papers also have same, a similar type, almost similar type of questions. So therefore, better you try 2011. But if you are interested, if you have time, you can start from 2000. If you want, you can go for the 1980s, 1990s. But the problem is, the thing is actually whether you have that much of time to do the past papers, right? Very old past papers. Okay. So I think, right, my idea, my suggestion is after 2011, after 2010, past papers are in. Okay. Question number 21. So then why you are discussing these old past papers 1980s from 1980s? Because first of all, you have to practice kind of MCQs from the first unit. I need you all to practice these questions. Then only you will understand what are the question types we are getting. So we are starting the past paper discussion now only, right? So this is the first session we are doing for the past papers. So therefore, let's practice how to do the questions. Let's try to understand how the question patterns will come by analyzing these past papers. Okay, right. Question number 21. The atomic mass unit is accepted as 1.66 10 to the power minus 24 grams. Is that correct? Atomic mass unit? Yes, that is correct. While exactly 1/12 of the mass of a carbon atom is taken as the atomic mass unit, and there are 6.022 10 to the power 23 carbon atoms in exactly 12 grams of carbon. Yes. Now look at this one. Students, when we discuss about the mass of the atom, I told you that we have a unit known as atomic mass unit, right? So what is the atomic mass unit value? We can say that 1.661 10 to the power minus 27 kilograms is the atomic mass unit, right? So another way that we can define the atomic mass unit is actually 1/12 of the carbon 612 isotope is considered as the atomic mass unit, right? When you consider the mass of the carbon 612 isotope and divided by 12, you will get the atomic mass unit. That's how they have defined the atomic mass unit. So therefore, the first statement is correct, right? Second one, while exactly 1/12 of the mass of a carbon atom is taken as the atomic mass unit, there are 6.022 10 to the power 23 carbon atoms in exactly 12 grams of carbon. What do you think? We know that, students, 12 grams of carbon is actually 1 mole, right? We define the molar mass of carbon as 12 grams per mole. So in 1 mole, how many particles are there? How many carbon atoms are there? Avogadro number of particles are there. 6.022 10 to the power 23 particles are there in 1 mole. So this is known as Avogadro number. So therefore, they have given while exactly 1/12 of the mass of a carbon atom is taken as the atomic mass unit, there are 6.022 10 to the power 23 carbon atoms in exactly 12 grams of carbon. Right. I'll tell you the mistake in this question. The mistake in this statement is they haven't given exactly carbon 612. They have given just carbon atom. We know that the carbon atom is represented by carbon 613 also. There are many isotopes. Carbon 614 also there. So therefore, can we take carbon 613 and carbon 614 to define the atomic mass unit? No. Atomic mass unit is defined by 1/12 of the carbon 612 isotope. We can't take carbon 613 or we can't take carbon 614. So therefore, just giving carbon atom is not enough. Therefore, answer is for this one, third one. Second statement is wrong because of this issue. They haven't specified the carbon isotope, which one we have to take to measure the atomic mass unit. So question number 21, answer is third. First statement is correct. Second statement is wrong. Therefore, question number 21, answer is 3. Right? Shall we go for the next one? Question number 22. The size of atomic nucleus was first determined by making use of alpha particle scattering. I think that should be the answer, but let's go for the others also. Making use of beta particle scattering. We haven't learned something like that. We have learned that Rutherford and his two students, Geiger and Marsden, conducted an experiment known as gold foil experiment. Another name is there for that one, alpha particle scattering experiment, right? So the reason that they have given alpha particle is the source of the particles that they have used is alpha. So that's why alpha particle. We haven't learned something like beta particle scattering, wrong. Using high speed electrons, wrong. Using neutron beam, that is also wrong. Making use of alpha particle scattering. Number 1 and number 5, both the statements are same. So therefore 1 and 5 both are correct. Okay. 1 and 5 both the statements are correct. You making use of alpha particle scattering. Question number 22, answer is 1 and 5 both correct. Right? These are completely theories, direct theories. Question number 23. Which one of the following statements concerning the particles used by Geiger and Marsden in the experiment that provided the basis of the nuclear model of the atom is more appropriate? So 1997 is also given that kind of a question, right? In again 1998, they're asking the same question in different, right? Look at the answers. Accelerated particles were used by Geiger and Marsden. What accelerated particles? They haven't specified whether it is alpha or beta or gamma or whatever it is, they haven't mentioned. Cathode rays, no. Accelerated cathode ray particles, no way. Accelerated neutrons, no. They have used actually alpha particles. So therefore, all of the above statements are incorrect. Question number 23, answer is number 5. Question number 23, answer is number 5. Next one. Question number 24. For the determination of atomic numbers of elements, atomic spectra were used, emission spectra and absorption spectra were used, X-ray spectra was used. Yes, I told you that atomic number was found by using the X-ray. Found by whom? Henry Moseley. So therefore, question number 24, answer is third one. See how easy these things are. These are direct theories. Ne? Let's go for the question number 25. So in the question number 25, correct that one. They have given 4 statements A, B, C, D. They have typed their E, F, G, H. Correct that one as A, B, C, D. Okay. Which of the following statements concerning electron are true? Right. Electrons want to move in a curved path in the magnetic field. Yes, students. That is the way actually. Electrons are actually moving in a curved path. You will learn this one in detail. In physics, actually, we have an unit known as magnetic field. And there actually you will learn that the electrons are moving in some kind of a curved path, right? So therefore, that's correct. Electrons have both particle and wave properties. Yeah. According to the de Broglie's equation, we know that. What are the de Broglie's equation, students? Lambda equal h over mv. According to this equation, we know that lambda is actually wave property, m is actually particle property. So the wave property and particle property can be seen in the equation. At the same time, we can say that electrons can show both particle and wave nature. So therefore, that's correct. Electrons cannot be added or received from an atom. Wrong, right? Then how ions can be formed, right? Cations are formed by releasing electrons, removing electrons. Anions are formed by gaining electrons. So therefore, that is wrong. The speed of electron is equal to the speed of light. No way, students. Remember, we have learned that speed of light is actually 3 into 10 to the power 8 meters per second. When you compare the velocity of electron, actually the velocity of electron is actually lesser than 1% of, right? 1% of velocity of light. Less than that. Okay. So therefore, we cannot say that they are equal, right? That is wrong. So 25, answer for this one. A and B statements correct. Question number 25, answer is first one. Question number 25, answer is first one. Okay. Students, anyone here who completed this tutorial completely? Anyone here, please raise your hand who completed this tutorial, the tutorial that I gave you. Raise your hand. Anyone here? Sir, I completed this tutorial. Anyone? At least 80% of the tutorial. Anyone here? 80% of the tutorial. Please raise your hand. Be honest, huh? Tejashwin, Helindu, Emanshi, Eshani. Very good. Very good. I'll give you the same kind of a tutorial for the second unit and third unit. You have to complete them. Huh? I told you, right? For the online students and physical students, for them, both of them, for both the batches, I told you that how much the questions you will practice, how much the questions, the papers that you will do, that much of knowledge you will gain, right? Then that is very easy for go for the examination and answer for the examination paper properly. So therefore, practice lot of questions. Okay, don't think that we have still time. We are doing the examination in 26, so therefore, nothing to worry. So start now, right? So start work now. එක දිගට ගැම්මට වැඩ කරන්න 20ක් වගේ වැඩ කරගෙන යන්න දැම්ම පටන් ගන්න. හරි? අන්තිම මොහොත වෙනකන් ඉන්න එපා. මේ ටියුට් ඔක්කොම ඉවරයක් කරන්න ඕන. හරි? මේවයි ප්‍රශ්න ඔයගොල්ලෝ ඇන ඇන අහන්න ඕනේ. මේ ටියුට් දෙන්නේ මේ නිකන් තියාගන්න නෙමෙයි, right? So therefore you have to do that. Right. I know that some students are actually really mostly working. They're asking a lot of doubts. They are doing questions. They are doing papers even. So I really appreciate them. But others also should work like that. So I'm encouraging others also to do work like that from the beginning. Then only you can go for a good result, right? If not at the end, don't think that I can do this one in this month. මාස 3-4න් මේක කරගන්න පුළුවන්. එහෙම නෑ හරි. මුලින් ඉඳලා හරියට වැඩ කරගන්න. ඔය average ළමෙක් නම් if you are an average student, you have to work from the beginning properly. හරි. මුලදී පොඩ්ඩක් slow වෙන්න පුළුවන්, පොඩි lag එකක් තියෙන්න පුළුවන් ඔයගලන්ගේ. නමුත් if you continuously work, if you believe in your consistency, continuously work, then definitely you will gain a good result, right? ඒකින්ද ඒක ඔළුවේ හොඳට තියාගෙන වැඩ ටික කරන්න. Right. Question number 26 ne? Yeah. Chemical and physical properties of isotopes are similar. Is that correct? No, students. Chemical properties are similar, but physical properties are not same because of the mass. Isotopes have the same number of protons, but a different number of neutrons. Is that correct? Isotopes have the same number of protons, but different number of neutrons. Yeah, that's correct. So therefore, we can say that question number 26 answer. Question number 27. Which of the following get deflect when moving across a magnetic field? Neutron? No way. Cathode rays? Yes. Proton? Yes, possible. Helium atoms? Helium atoms are neutral. Only charged species are deflecting in the presence of magnetic field or electric field. So therefore, we can't get the answer. B and C correct. Question number 27. Answer is second. Right? Question number 27. Answer is second one. Question number 28. That is also easy. Related to the isotopes. A certain sample of carbon monoxide has only carbon 614 and oxygen 616 isotopes, right? So carbon monoxide sample එකක් තියෙනවලු. So that sample is made by carbon 614 isotope and oxygen 816 කියලා හදාගන්න එතන, right? So it should be corrected as oxygen 816 isotopes. Another sample of carbon monoxide has carbon 612 isotope and carbon 818 isotopes, right? Look at this one. There is a sample of carbon monoxide. That carbon atom is made by carbon 614 isotope and oxygen is made by oxygen 816 isotope. Another sample is there, carbon 612 isotope and oxygen is 818 isotope. The property that shows a significant difference between the two samples. Students, we know that if you are given two isotopes of the same element or the same molecule, what is the, where you can see the significant change? In which property you can see that significant change? In mass, right? Directly we can tell that in mass. If not, we can tell mass percentage, right? If not composition, right? So therefore, directly we can see the significant change in the mass. Let's see whether they have given the correct answer. Chemical reactivity. Chemical reactivity is same because same number of electrons. Molar mass. What do you think? Molar mass, is that correct? Molar mass. Mass of 1 mole. No, molar mass is not changing. Carbon monoxide, when we take the average value, the molar mass is same, right? Because actually there we are considering the mass of 1 mole. So therefore it can be same. Molar volume, no. Density at standard temperature pressure. STP means standard temperature pressure, wrong. Percentage composition of carbon and oxygen by mass. Yes, it is changing. Percentage composition, if you take the percentage value, that percentage value can be changed, right, by the mass. So therefore, question number 28, answer is number 5. Question number 29. Which of the following statement is true? An atom of tin 50, 118. Look at this one. They have given an isotope of tin, SN 50, 118 in this way. So first of all, let's count the electrons. Yeah, element is given 50. Number of protons 50. So the neutrons count can be taken by 118 minus 50. So therefore the answer will be 8 and here 68. It has 50 electrons, correct. It has 50 protons, correct. It has the total number of 118 electrons and protons. Total number of 118 electrons and protons. Is that correct? So the total count of electrons and protons will be 50. That is wrong. It has 68 neutrons, correct. A statement is correct. B also correct. C is wrong. D is correct. Therefore, question number 29, answer is 5. Option is 5. Go for the next page. Those things are very easy. Right. Which of the following column 1 to 5 correctly matches the name of each scientist in the column with the activities in the activity column? Students, they have given 3 activities. Without looking at the answers, shall we get the answers by looking at the activity? What are the activities they have given? Let's see who did this activity or who contributing for this one. First one, they have given propose the nucleus model. Propose the nuclear model of atom, right? Then next one is interpreted the atomic spectrum of hydrogen. Yeah, you know that. Atomic spectrum of hydrogen. Interpreted. Next one, determine the charge over mass ratio of an electron. Right? You know that nucleus model proposed by Rutherford. No doubt about it. Atomic spectrum of hydrogen interpreted by using the energy level model, Niels Bohr. And you know who is the next scientist? Thomson. Then Rutherford, Bohr, Thomson. This answer is given in the second option. Question number 30 answer is second one. Question number 30 answer is second one. Question number 31. Which of the following statement are true? Electrons have particle as well as wave properties. Yes, we discussed that one according to the de Broglie's equation. A proton is heavier than neutron. Is that correct? So I told you that at the beginning. What is the mass of an proton? When you compare the mass of these three particles, we can say that mass of electron is 9.107 10 to the power minus 31 kilogram. Mass of a proton is 1.672 10 to the power minus 27 kilograms. And the mass of a neutron is 1.675 10 to the power minus 27 kilograms. So when you compare the masses, actually the least mass belong to electron, then proton, the greatest mass belong to neutron. So therefore we can tell that here a proton is heavier than neutron. Wrong. All atoms have electrons, protons, neutrons. What do you think? Is that correct? Students, when you consider protium, the first isotope of hydrogen, number of electron is 1, proton is also 1, neutrons are 0. So therefore, every element has electrons, protons, neutrons. That is wrong. Why? Neutrons actually having, there is hydrogen element. Hydrogen element doesn't contain any neutrons. So therefore, yeah. So that is wrong. All ions have at least one proton. Yes, we know that. Even though when you consider H plus cation, hydrogen is forming H plus cation. Even in H plus cation, we can say that proton is there. A and D statements correct. Question number 31, answer is 4. Question number 31, answer is number 4. Okay. Next one, question number 32. Which of the following statement is incorrect regarding isotopes of an element? They have same number of electrons. Is that correct? They're asking incorrect statement, right? They have same number of electrons, correct. Then they have the same density. What do you think? Density. Can we say the density is what? Which of the following statement is incorrect regarding the isotopes of an element? They have same density. Since the mass is changing, we can say that density is changing, no? So therefore, I think answer should be second one. But let's go for the other statements also. Similar chemical property is correct. Different number of neutrons, that's why isotopes are existing. Same number of protons, yeah, correct. Question number 32, answer is second. Very easy. Question number 33, the number of electrons and the number of neutrons present in the magnesium 1225 isotope, and it is forming 2 plus cation respectively. Magnesium 1225 2 plus cation. How many electrons are there? 10. How many protons are there? 12. How many neutrons are there? 13. Okay. So they're asking number of electrons and the number of neutrons. 10 and 13. Answer is third one. Question number 33. Answer is third option. Very easy, ne? Question number 34. The following scientist identify who was not connected with the development of atomic theory. Niels Bohr. Niels Bohr has a huge contribution, right? Where we learn the energy level concept and everything because of the Niels Bohr. J.J. Thomson, yeah, he also had some kind of a contribution at the earlier time because of the discovery of electron and plum pudding. Chadwick, what do you think? Yes, Chadwick also has some kind of a contribution because of the discovery of the neutron. Let's go for the fifth one, Rutherford. Yes, Rutherford is actually the one who found the atomic nucleus, right? And the Linus Pauling is actually the one who found the electronegativity, a scale of the electronegativity, right? So we have to discuss about the electronegativity part in the first unit. I will put the recording. I told that students. Electronegativity means actually the ability to pull the electrons from an atom when they are forming chemical bonds. So Linus Pauling introduced a scale for the electronegativity to measure the electronegativity. How much capable of pulling electrons from a chemical bond for an atom is known as the electronegativity. So therefore, he is actually not contributed for the development of the atomic theory. Question number 34, answer is number 4. Okay. Next one, question number 35. Which of the following statement is not true regarding subatomic particles? What do you think? Electrons show both wave properties and particle properties. Correct. Electron is an atom are dispersed in three-dimensional regions of space around the nucleus referred to as orbital. Correct. Electrons are gathered. The where we can find out electrons with high probability in the three-dimensional space is considered as orbital. The neutron was detected when beryllium was bombarded with high energy alpha particles. Correct. That's how we told that neutron was discovered. The neutron is an uncharged particle with its mass approximately equal to that of proton. Approximately equal, up to the second decimal point, both of them are equal. The number of protons in isotopes of an element are different from each other. Is that correct? Number of protons are not changing. They are similar. So therefore, so answer for this one, they are asking about the not true statement. 35, answer is 5. Let's go for the next question. 36. The neutron was discovered by students very easy. James Chadwick. 36 answer is number 3. Neutron was discovered by James Chadwick. The plum pudding model of the atomic structure was put forward by whom? J.J. Thomson. 37 answer is second one. 38. 38 students in that question. Put that one. This is 2016 A level. This question is incompleted. Put there lambda. Lambda is actually 4.42 10 to the power minus 7 meters. Now do the calculations and get the answers. Let me do with you. Right, students, we learned about the electromagnetic spectrum, electromagnetic radiations. Right, in the electromagnetic radiations, we learned that according to the Planck's theory, Max Planck's theory, energy, right, energy that released or gained by electrons, released or absorbed by electrons when they are shifting between the energy levels is directly proportional to the frequency, right? So therefore, this proportionality symbol can be eliminated by adding the Planck's constant equation, right? Then we know that we have another equation known as C equal nu lambda, which you learn in your O-level time. By combining these two equations, we develop another equation which is known as E equal hc over lambda. Understood? So this is actually giving energy of a photon. A photon means a small particle. When you consider the energy is actually quantized. So that quantum particle is known as photon. Energy of a photon is given by E equal hc over lambda. Then here they are asking what is the question. The energy of a photon of the green light if the lambda is given in this way. How do you find out? We know that Planck's constant 6.626 10 to the power minus 34 joule seconds. Velocity of light is 3 into the power 8 meters per second. Divided by lambda 4.42 10 to the power minus 7 meters. Meters will cancel off. Second per second will cancel off. Right? Is there anything simplifying here? Yeah. So we can say that 6.626 multiplied by 3 divided by 4.42. And here we have 10 to the power minus 19 joules. Students, the log value for the 6.626 is, as I can remember, 0.8213. But let's see. Do the log calculations with me. 6626. Yeah, and the log value is for 3 is 4771. So summation 4, 8, 9, 12, 1. And the log value for 44 2 will be 6454, 0 point, and the difference is 0, 3, 5, and here 6. So 0.6530. 6530 antilog. 44, 9, 8. 4498, 10 to the power minus 19 joules. So approximately we can tell that 4.5, 4.5 10 to the power minus 19 joule will be the correct answer for this one. So this answer they have given in kilojoules, students. So how do you convert joules into kilojoules? What you have to do? In order to convert joules into kilojoules, you have to multiply that one by 10 to the power minus 3. Then 4.5 10 to the power minus 19 minus 3 kilojoules. 4.5 10 to the power minus 22 kilojoules. So this answer is given in the fourth one. Question number 38, answer is fourth. Question number 39. The scientist who proved Thomson's plum pudding model of atomic structure disproved. Disproved means actually Thomson's plum pudding model is actually wrong. Who said that one? After Thomson, the one who gave the idea about the atomic model is Rutherford. Rutherford proved that one. The Thomson model is wrong. So now Thomson said that atoms look like a positively charged sphere and electrons actually embedded on it like plums are on a pudding. So therefore that is wrong idea. Right? So therefore Rutherford is the guy, Ernest Rutherford. Question number 39. Right. So these are the past papers they have given up to 2017, 18. I'm going to discuss last 5-year past papers separately. Again, 19, 20, 21, 22, 23. These 5 papers I'm going to take separately and I'm going to discuss those questions separately after the completion of the tutorial. Okay. Because let's better we discuss the last recent year past papers separately. Okay. Then using the atomic theory, atomic models, atomic number, mass number, isotopes, these are the past papers that they have given. Remember, students, by looking at the questions, I think you might wonder that these questions are manageable, right? You can easily go for the answers. So now we considered about 40 questions again. So easily you can go for the answers for these 40 questions, right? If you can get 40 out of 38, 37, that is actually okay level, right? Sometimes we are doing careless mistakes in the examination. So therefore, some marks will reduce, but you have to reduce those careless mistakes. Okay. Okay. Right. Now we can go for the next topic. The questions which are given from the next topic: hydrogen emission spectrum, electromagnetic radiations, de Broglie's equation. So that topic. Okay, let's quickly go for that one also. So students, our next topic is actually electromagnetic radiation spectrum and quantum numbers. I summarized that topic. So let's see what are the questions they have given in this topic. Let's quickly finish. Let's see how many questions are given in this topic. So they have given 48 questions from this one. Let's finish this one also. Right. Number one, X-rays were discovered by Thomson, Becquerel, Roentgen, Marie Curie, mostly. We learned that X-ray was discovered by whom? Wilhelm Roentgen. So therefore, question number one answer is third one. Question number two, an atomic nucleus is composed of protons only. Wrong. Neutrons only. Protons and neutrons only. That is also wrong. Why? There are other particles also, right? Now in modern science, they have found protons, neutrons, and other fundamental particles. Correct. Equal number of neutrons and protons, electrons. Wrong. So therefore, we can consider that. Question number two answer is fourth. Question number three. Cathode rays are deflected by a magnetic field. Is that correct? Yes, that is correct. Cathode ray contains positively charged particles, so that is also wrong. Cathode rays are not positively charged. First statement is correct, therefore answer is. Question number four. A student made the following statements about the atomic spectra of hydrogen. Which of the statement is incorrect? Let's see. The series of lines in the infrared region of the spectrum is called the Lyman series, right? Each line of the spectrum corresponding to a different definite radiation. The series of the lines in the visible region called Balmer series. The principal lines in the Balmer series are termed as H alpha, H beta, H gamma. They haven't given H delta. Right? Number five, the atomic spectrum is caused by the transition of electrons between energy levels, right? Anyhow, let's revise the hydrogen emission spectrum quickly. Can you remember, students? In hydrogen emission spectrum, we know that these are the corresponding energy levels. Energy level diagram can be drawn in this way, right? Electrons are falling to the lower energy levels from high energy levels. In this way, okay? All the electron transitions possible for the first principal energy level is known as Lyman series. And students, we know that Lyman series belong to the ultraviolet region in the electromagnetic spectrum, right? And here we can see that these are the electron transitions falling to the second principal energy level, and this is considered as Balmer series. Balmer series is actually partly visible. That means we can see the very first four lines of the electron transitions, H alpha, H beta, H gamma, H delta, right? So H alpha is red color, H beta is green color, H gamma is blue color, and H delta is purple or violet color. So therefore, these are the four lines that we can see for our naked eye in the atomic hydrogen emission spectrum. And then we have Paschen series, all the electron transitions falling to the third principal energy level. So this is Balmer. Balmer is partly visible. Partly visible. And Paschen is considered as IR region. And then bracket Fun Humphrey, likewise, we have so many series. So this is hydrogen emission spectrum energy level diagram that we learned. Okay. Then you can see that, students, the first statement is incorrect. No, the series of the lines in the infrared region of the spectrum is called Lyman. Wrong. Paschen, bracket, fun, they are belongs to IR region, right? Lyman directly belongs to ultraviolet region because Lyman has the greatest energy and the greatest frequency in the hydrogen emission spectrum. For this direction, we can tell that energy and the frequency increasing, right? Then what will happen to the lambda wavelength? That is decreases. First statement is wrong. Each line in the spectrum correspond to a definite radiation. Yes, right? They are emitting radiations. So the energy of the radiation is denoted by that line in the spectrum. Then the series of the lines in the visible light region called Balmer series, correct. The principal lines in the Balmer series are known as actually H alpha, H beta, H gamma, H delta. Correct that statement, students. The principal lines in the Balmer series is known as H alpha, H beta, H gamma, H delta. Correct that one, that statement. The spectrum, the atomic spectrum is caused by the transition of electrons between energy levels. So this emission spectrum is actually obtained because of the electron transition between the energy levels, right? So question number 4, answer is number 1. Number 5, cathode rays are penetrate through very thin aluminum foil. Yeah, cathode rays can go through that one, no issue. Cathode ray constitute of alpha particles, wrong. Question number 5 is third one. First statement is correct, second one is wrong, therefore answer is number 3. Question number 6. Which of the following statement or statements about alpha particle are true? Alpha particles have a high penetrating power than beta particles. Can you remember? I told you that which one has the greatest penetrating power? Gamma. Second highest one is beta. The least penetrating power belongs to alpha. That is wrong. Alpha particles have higher ionizing power than beta particles. What do you think? Yeah, that's correct. When you consider the ionizing power, the greatest ionizing power belongs to alpha, then beta, then gamma. Alpha particles produce helium gas. After gaining electrons, after gaining 2 electrons, alpha particles can form helium. That's correct. B and C statements are correct. Alpha particles are not deflected by a magnetic field. What do you think? That is wrong. B and C statements are correct. We can say that question number 6 answers true, because B and C statements are correct. Let's go for the question number 7. The ionizing power of alpha particles is greater than the ionizing power of beta particles. Correct. The mass of alpha particle is very much greater than the mass of beta particles. Is that correct? We know that we discussed this one. Alpha particles means helium nucleus. In the helium nucleus, we know that 2 protons and 2 neutrons are there. In beta particle, we have just electron. So therefore, we can consider that statement is correct. Students, will the second statement is explaining the first, right? So this is something very important to discuss, right? We know that we know that the ionizing power of alpha particles is greater than the ionizing power of beta particles, correct? So that is correct. That is okay, fine. The mass of alpha particle is greater than, very much greater than the mass of beta. That's also correct. Is that the reason for having greatest ionizing power for the alpha? What is the reason? What could be the reason that alpha particles have greater ionizing power than beta, than gamma? Because of what? What do you think? It's not because of the, remember students, not because of the mass. It is because of the charge. We know that gamma is anyway neutral. Gamma is neutral. Then we can say that alpha particles are positively charged, but charge is +2. Beta particles are negatively charge is -1. So in charge wise, who is greater? Alpha. Ne? So therefore we can say that here charge matters. So therefore we can say that answer for this one is second. Question number 7, answer is second one. Second statement is not explaining the first one properly. So second question number 7 also answer second. Let's go for the question number 8. Which of the following statements are is true? In a strong magnetic field, beta rays are attracted towards the N magnetic pole. Is that correct? In a strong magnetic field, beta rays are attracted towards the N magnetic pole. I told you electrons neither attracted to north pole nor south pole in a magnetic field. In a strong magnetic field, beta rays are attracted towards the S magnetic pole. No way. In an electric field, alpha rays repelled by the positively charged plate. Correct, because alpha rays are positively charged. In an electric field, gamma rays are not attracted towards the negatively charged plate. Right, what do you think? In an electric field, gamma rays are not attracted towards the positive negatively charged plate. Gamma rays are going in the path that already started in the same way without any deflection, because gamma rays are neutral. C and D correct. Question number 8 answer is third. Question number 9, look at the patterns. Right, in the tutorial they have given which one of the following patterns of lines in most closely connected with the proton of lines of atomic high emission spectrum of hydrogen. That means they are asking which one can see the, in which diagram we can see the hydrogen emission spectrum. Anyway, you can see that the first one we can't take. They have just given lines with no space. So just random lines, not correct. Second one actually we don't see that the line gaps are properly given. So second one is also not accepted. Third one, in the third one issue is for one direction frequency is decreasing, for the other one is frequency increasing. So we don't have that pattern. For the same direction frequency should increase or wavelength should increase. Fourth one is fourth one is also wrong, right? They have given the similar gaps, wrong. None of the above. Question number 9 answer is 5. None of the above. We don't see any correct pattern that we learn in here, right? Question number 9 answer is 5. Right? Next one, question number 10. The charge that can exist on a cathode ray particle was quantitatively determined by, we know that charge is determined by Millikan, but the answers they have given mostly Rutherford, Thomson, Marsden. Correct? No, none of the above. Question number 10, answer is number 5. Right. Now let's move for the question number 11. Which of the following statement concerning alpha, beta, gamma rays are incorrect? First one, the path of the alpha rays is changed by magnetic field. The path of the alpha rays is changed by magnetic field. Yes, correct. The path of the beta rays is changed by electric field. Correct. The ionizing power of gamma rays very high. Wrong. The penetrating power of alpha rays very high. Wrong. A and B statements correct. Therefore, question number 11 answer is number 1. A and B. Okay. Right. Okay, students, let's have a small break. After the break, let's start to discuss the other questions. Okay. Now time is 10. Have a quick break, about 10 minutes. Okay. After the break, let's discuss the remaining question. Right, okay. Let's move to the next question. Question number 12. Right. The penetrating power of beta rays is very high. What do you think? Is that correct? We know that actually among the alpha, beta, gamma, the penetrating power, the highest penetrating power belongs to actually not for the beta, that should be gamma. So therefore, that is wrong. Beta rays are electrons traveling at high velocities. Yeah, that's correct. That's correct. So therefore, question number 12, answer is 4. Question number 13, which one of the following statement concerning alpha rays is not true? The penetrating power of alpha rays is low, correct. The ionizing power of alpha rays is high, that's also correct. Alpha rays travel with a velocity which is almost equal to light. That is again wrong. We know that actually, remember students, gamma rays actually having, gamma rays means actually we can tell that a type of electromagnetic radiations. So therefore, we can say that they actually can travel with the speed of light, gamma rays, but alpha beta particles cannot travel in the speed of light. That is wrong. Sorry. So therefore, alpha rays travel with a velocity which is almost equal to that of light. Wrong. I think that should be the answer for this one. But let's see. The path of alpha rays is changed by electric fields. What do you think? Yeah, that's correct, because alpha rays are positively charged particle. In the presence of electric field, alpha particles are going for the negatively charged plane. The path of alpha rays is changed by magnetic field. Yeah, that's also correct. Question number 13, answer is third one. 14. Which of the following statements concerning isotopes are true? Oxygen 18 is radioactive. Fluorine 19 is radioactive. Phosphorus 32 is radioactive. Cobalt 60 is radioactive. Remember, students, oxygen actually not forming or radioactive isotopes. Oxygen 18 is not radioactive. Fluorine is not radioactive. Fluorine 19, but phosphorus 32 and cobalt 60, they are radioactive. Right. So question number 14 answer is third one. Next one, which one of the following patterns corresponds most closely with the position of lines of the spectrum of atomic hydrogen? So look at the given answers. So normally when we draw the hydrogen emission spectrum, spectral line diagram, the spectral line diagram of the hydrogen emission spectrum, that should be like this one. The spectral line diagram for the emission spectrum. We know that the lines actually in this way. So we can say that this is Lyman series, Lyman UV. And the gaps are reducing, right? Now, when you go for the Balmer series, okay, so this is Balmer series. Balmer is actually partly visible light region. And then again, we have partial. Then lines are becoming very close to each other. Then this is considered as partial, belongs to IR region. So therefore, this kind of a pattern can be seen in which answer, right? They have given the opposite also. Yeah, when you consider the opposite, that means this is frequency increasing mode. For this direction, energy and the frequency increasing. and lambda wavelength is decreasing. So what is the other pattern? That means when you consider for this direction energy and frequency decrease and the lambda wavelength is increasing, then the pattern should be like this. We can say that these patterns should be exchanged. No, this should come here and the others come here. So therefore, the correct option should be among 1, 2, 3, 4, 5 answers. The first one is the correct answer. Question number 15. Answer is number. For the question number 15, answer is number 1. Okay. Then question number 16. Which of the following statements concerning atomic spectra is true? As the frequencies of the lines of the spectrum of hydrogen increases, the lines rapidly come close together. Yeah, as we discussed, we know that when we consider the hydrogen emission spectrum, students, for this direction energy and frequency increasing, did you notice that the spectral lines also coming closer to each other, right? Even in the energy level diagram, we can see that one, right? When we go for the direction where energy and frequency increasing, the gaps between the lines are decreasing for the direction where frequency is increasing. So that statement is correct. As the frequencies of the lines of the spectrum of hydrogen increases, the lines rapidly come closer together. Yes, correct. Second statement, as the frequencies of the lines of the spectrum of hydrogen increases, the lines move away. Wrong. The frequency difference between successive lines in the spectrum of hydrogen remain constant. No, if it is remain constant, we should notice that the gaps between all the lines are equal. So therefore, that's wrong. Hydrogen gives only an emission spectrum. No, we have discussed about the atomic absorption spectrum and the atomic emission spectrum of hydrogen. So therefore, the fourth one is wrong. Hydrogen gives only absorption. Wrong. So therefore, question number 16 answer is first one. Question number 16 answer is first one. Next one. Which of the following statements concerning gamma rays are true? Gamma rays travel with a velocity of 90% of velocity of light. No, students, gamma rays have the exactly same velocity of light because gamma rays actually electromagnetic spectrum. So therefore, that is wrong. The ionizing power of gamma rays is very high. Not the ionizing power, it is penetrating power. The penetrating power is the greatest in gamma rays. Wrong. The penetrating power of gamma rays is very high. Correct. The path of gamma rays is not altered by magnetic fields. Correct. C and D. Question number 17 answer is third one. 18. Electric fields do not affect the path of cathode rays. Is that correct? No, cathode rays are deflecting towards the positive plate of the electric field. Magnetic fields do not affect the path of cathode rays. Wrong. Magnetic fields actually affecting. Electric fields do not affect the path of the fast moving neutrons. Correct, because neutrons are neutral. So therefore, actually, they are not affected. Magnetic fields do not affect the path of fast moving neutrons. That's also correct. So therefore, C and D correct. Question number 18, answer is third. Right. Next one. Question number 19. Cathode ray particles are negatively charged. Travel in a straight lines. Both are correct. A and B statements are correct. Are attracted towards the N magnetic pole, are attracted towards the S magnetic pole. So normally, just now we discussed that they are not attracting towards the NO S magnetic pole. So therefore, 19 answer also. Here we can say that first one is the answer. Question number 20. Which one of the following statements pertaining to atomic spectra is false? Atomic spectra can be studied as emission spectra. Right? So that's correct. Atomic spectra can be studied as absorption spectra. That is also correct. The spectral lines of an atomic spectrum occur as several clearly distinguishable series of lines. Students, Lyman series, Balmer series, Paschen, bracket, fun. Likewise, we have several distinguishable series in the emission spectrum. Correct. The dark lines of an absorption spectrum do not occur as several clearly distinguishable series of lines. That is wrong. We know that, anyhow, we learned that in the absorption spectrum, we can see that dark lines appeared on a bright background. Because students, in the absorption spectrum, what will happen is the electrons are going for the high energy levels by absorbing the energy. So therefore, the dark lines are representing that some of the energies are missing because of the absorption by electrons in the hydrogen. So still we can see these series, Lyman, Balmer, Paschen. Likewise, we can see the series patterns, right? So whether it is absorption or emission, right? Whatever the spectrum, you can see that. And in the emission spectrum, we can see that bright lines in a dark background, because some of the radiation is actually emitting. That means we can see it. Especially the Balmer series line can be seen for our naked eye because they belong to the first four lines is belong to the Balmer series. First four line belongs to the visible light region. Red color, green color, blue color, violet color. We can see these four colors, right? Then that is correct. So the dark lines of an absorption spectrum do not occur as several clearly distinguishable series of lines. Wrong. There is no direct relationship between a given height line of an atomic spectrum and a certain energy level under consideration. There is no direct relationship between a given height line of an atomic spectrum and a certain energy level. This line and the energy level doesn't have energy level diagram. Can you remember? In energy level diagram, energy levels and this line doesn't have any direct relationship, because we know that, what did I teach you in the theories? I told you that these lines in the emission spectrum is explaining what? The energy gap between the energy levels, not the energy levels. Energy gap between energy levels, right? So for example, when I consider this line is representing when the electron is coming from sixth principal energy level to first principal energy level, the emitted energy is represented by this line. That means that emitted energy is equal to the energy gap between the sixth principal energy level and the first principal energy level, right? Try to understand. Question number 20, answer is 4. You have to be very careful when we are going for the statement type of questions, right? Because I have seen that most of the students are doing calculations nicely, and they are struggling in these kind of statement type of questions because lack of practice actually. Okay, you have to practice. Next one, D over M ratio cathode rays were first shown by a constant by Millikan, Faraday, Rutherford, Chadwick, none of the above. We know that actually that is shown by Rutherford. So therefore question number 21, answer is number 5. Question number 22. Which of the following statement are true? Alpha particles are attracted towards the atomic nucleus. Is that attracted or deflected from the nucleus? According to the Rutherford's gold foil experiment, alpha particles are deflecting from the nucleus, right? Cathode rays are not attracted towards the S pole, correct? Positive rays are not attracted towards the N pole, correct? The velocity of alpha rays is greater than the velocity of X-rays. Friends, remember, in a vacuum, X-ray is also electromagnetic radiation. In a vacuum, it has the velocity of light. So therefore, how we can say that velocity of alpha particles are greater than X-rays? That is wrong. Question number 22, B and C statements are correct. Therefore, answer is number 2. Question number 23. The emission spectrum of the hydrogen atom and the emission spectrum of lithium atom are very closely similar. Wrong, right? I told you that No two elements can have the same emission spectrum, right? If they have the same number of electrons, we can say that, yeah, they have same line patterns, but their emission spectrums are not completely same. In the value wise, if you take the energies, right now, for example, hydrogen is there, helium plus is there, because helium plus is also having just one electron. Can we say that hydrogen and helium plus both have the same emission spectrum? No, we can't say. The reason is helium plus is containing what neutrons in the nucleus, right? And the two protons are there. So those are actually affecting to the emissions and absorptions. So therefore, energies involved in the helium plus is completely different from the hydrogen. Maybe the line patterns can be equal, but the complete emission spectrums are not equal. Try to understand. But here they have given hydrogen and lithium. Hydrogen is having one electron, lithium is 3 electron system. So therefore, we can't say that. Hydrogen and lithium atoms have only one electron in each their outermost energy levels. Yeah, correct. Because we know that we discuss about the electron configuration. Hydrogen is 1s1, lithium is 3 means 1s2, 2s1. In their last valence energy level, there is only one electron. That statement is correct. First one is wrong, second one is correct. Question number 23, answer is number 4. Right. Let's move for the question number 24. Which of the following statement is correct regarding the atomic spectrum of hydrogen? N equal 2 to N equal 1 transition has the longest wavelength. Is that correct? In the Lyman series, we know that this is 2 to 1, 3 to 1, 4 to 1, 5 to 1. Likewise, we have the wavelengths, electron transitions. Remember, for this direction, we know that the frequency and the energy increasing, and the lambda wavelength is decreasing. But remember, not only the Lyman series, there are some other series as well, Balmer, Paschen, Brackett, Fun. So therefore, we cannot say that the radiation corresponding to the N equal 2 to N equal 1 has the longest wavelength. That is wrong. In Lyman series, that's correct. In the Lyman series, the longest wavelength belongs to N equal 2 to N equal 1 transition. But when you consider the complete emission spectrum, there are some other series, Balmer, Brackett, Fun. So they also have the wavelength greater than Lyman. Therefore, the first statement is wrong. N equal 3 to N equal 2 transition corresponding to H alpha. Yes. I told you that H alpha means this is red color, this is green color, blue color, violet. So H alpha means we can tell that electron transition is N equal, what is it? N equal 3 to N equal 2. This is the electron transition from N equal 4 to N equal 2. This is N equal 5 to N equal 2. This is N equal 6 to N equal 2. Understood? So these are the corresponding electron transitions. So therefore, the second statement is correct. The first series of the lines, Lyman occurs in the infrared region. Wrong. Lyman, ultraviolet region. Balmer, partly visible. Paschen, Brackett, Fund. All these series belongs to IR region. Okay. Therefore, that is wrong. In a given series, the separation between adjacent lines increases in the direction of the increasing energy. This is the direction where frequency is increasing. What you can say about the gap? They're asking about uh, the separation between adjacent lines increases. Is that correct? Is it increasing order? No, this is decreasing order. So therefore, that is wrong. Emission of radiation occurs when electrons undergo transition to highest level from lower levels. Right? Is that correct? From lower levels to highest level. No, that is absorption. Remember, absorption occurs, absorption spectrum is occurred when the electrons are moving from lower energy level to higher energy level. Then the emission spectrums are obtained when the electrons are moving from high energy level to low energy level. So therefore, the fifth statement is wrong. Question number 24, answer is second one. Question number 24, answer is second one. Right? 25. So actually in the 25, I think we have to give all, but let's see. Which of the following statements are not true? Incorrect statement regarding the atomic spectrum of hydrogen. The transition from n equal 5 to n equal 2 corresponds to the beta line. H beta n equal 4 to n equal 2. So therefore the first statement they have given is wrong. The energy difference between n equal infinity to n equal 1 levels is the ionization energy of hydrogen. Yes, friends. Remember, ionization energy of hydrogen means hydrogen gaseous state 1 mole of atom is releasing 1 mole of electrons to form single valent gaseous state cation 1 at the standard temperature pressure. Then students, this electron is actually removed to the infinity level. This is going for the infinity level. So that is known as what? Ionizing. So that is, yeah, B is correct. We can say B correct. Each line in the spectrum corresponding to the energy level of the hydrogen atom. Completely wrong. Right? තාමත් සමහර ළමයි හිතන් ඉන්නවා emission spectrum එකේ අර අපි අඳින lines අපි spectral line විදිහට අපි ගන්න series එකේ මෙහෙම තියෙන lines, these are energy levels. Remember students, that's not correct. තාමත් ළමයි හිතන් ඉන්න එහෙම ළමයි ඉන්නවා. මේ තියෙන energy levels ලු. එහෙම නෙමෙයි, right? So these are actually the corresponding energies released when the electrons are transferring from high energy level to the low energy. That means simply we can say that these lines are representing the energy gap between the two energy levels when they are transferring from one energy level to another energy level, right? So therefore, we can say that that is wrong. The energy difference between n equal 2 to n equal level is smaller than the energy difference between n equal 3 to n equal 2. Remember students, in the emission spectrum, when we consider the energy level diagram, the highest energy level gap between, when you consider the two consecutive energy levels, the highest gap is always obtained between 1 and 2. Understood? The highest gap. Yeah, I'll explain B again. Remember, they have given n equal 1, n equal 2 and n equal 1 level is smaller than that of between n equal 3 and 2. Students, the energy level gaps are decreasing when going far away from the nucleus. So therefore, 1 and 2 consecutive energy level gap is greater than 2 and 3. So therefore, D statement is wrong. Right, okay. B, I will explain the statement B again. The energy difference between n equal infinity and n equal 1 level is the ionization energy of hydrogen. Remember, I told you that what does mean by the hydrogen ionizing? That means hydrogen is releasing one electron. So that means in the ground state, there is an electron in the hydrogen atom. So this is actually what? Going for what? The energy difference between n equal infinity to n equal 1. is the ionization energy of hydrogen. The energy difference between n equal infinity to n equal 1 is the ionization energy of hydrogen. Now look at this only. Look. n equal, we know that in the hydrogen atom, there is an electron in the first principal energy level. So that electron is released. That electron is released means definitely remember that it is going for infinity energy level, n equal infinity. Okay. So this is actually can be what? Absorption. Because they are going for high energy level, right? If they have given ionizing something, ionizing an element, the electrons in the ground state are going for the infinity energy level. That is the way. Then we can say that the ionizing energy, whether it is absorption or emission or whatever it is, the gap is always equal to the ionizing energy, right? In order to, we know that ionizing means the energy, minimum energy that is required to remove the electrons from the atom. So that electron is removed from this first principal energy level and taken to the greatest energy level n equal infinity. Then the energy gap between 1 and infinity is that ionization energy, right? So therefore only B statement is correct here, but they haven't given that kind of option. Can you understand? They haven't given this kind of option. We can consider here only B statement is correct. Answer is all. In the examination, if they haven't given you the correct answer, the marking scheme actually, they will make the marking scheme by giving all for that question. Question number 26. The order of filling electrons into the energy levels in atom in the fourth period of the periodic table. Right. We know that, students, Aufbau principle. Can you remember? When we discuss about the electron configuration, I told you that Aufbau principle. Aufbau principle actually explaining how electrons are filling to the atomic orbitals or the sub-energy levels. Right? Aufbau principle. According to the Aufbau principle, we can say that, right? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 5g, 6s, 6p. Right? Then here we have 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, likewise. So this is actually the Aufbau principle. Right? Electrons are filling in this way. To the atomic orbitals. What is the order? 1s, 2s, 2p, 3s, 3p. Then we have 4s, 3d, 4p, 5s. Likewise, it's continuing. So therefore, you can see that the correct order, right? Can you see this order? 4s, 3d, 4p. Question number 26. Answer is third one. Right? So this is the electron filling order. Question number 26. Answer is third one. Question number 26. Answer is third one, right? Shall we move to the question number 27? Which of the following correctly represent the arrangement of the emission lines in two consecutive series in the absorption spectrum? So students, according to the spectrum diagrams that they have given, what you can choose here as the correct option? So we can choose the first one, because first one is actually containing, we can say that is Lyman and Balmer together, right? Second one is wrong because of the arrangement should be different because the gap is decreasing for the other direction. Third one is also wrong. Fourth one anyway wrong. Yeah, the correct one should be first one. Question number 27, answer is first one. So that's very easy. By looking at the diagrams that I taught you, you can go for the answers. Right, okay. Now let's go for the next question. Page number 12, question number 28. The emission lines of Balmer series of the atomic spectrum of the hydrogens are shown below. They have given emission lines A, B, C. The colors of the lines A, B, C respectively, right? So normally we know that when we draw the Balmer series for this direction, energy levels in this way, just imagine this is principal energy levels in this way, line on. Now I'm drawing the series to the other direction. That means for the direction where the wavelength is increasing, right? Then this is actually Balmer series. Okay. So these are the lines A, B, C. Can you understand? These are the lines A, B, C. So when you draw the spectral line diagram, the spectral line diagram should be like this. Okay, then they have given the opposite direction. Lines are decreasing. No? We can say that students, when you draw the spectral line diagram in this way. Okay, so this is the place that where the gap is decreasing. That means we can tell that for this direction, frequency increasing. Okay, lambda wavelength is decreasing. Then what are the colors they have given? The three colors they have given is blue, green, red. So among these three colors, which one has the greatest frequency? Among the visible light region, we know that, but the visible light region colors are red, orange, yellow, green, blue, indigo, violet. And for this direction, we know that again frequency increasing and the lambda wave frequency increasing, lambda wavelength is decreasing. Now you can guess the colors. So what are the colors they have given? Red color, green color, and blue color. So you can see that same diagram, same order, frequency increasing, lambda decreasing, frequency increasing, lambda decreasing. So therefore we can say that A is red color, B is green color, and this one is blue color. Red, green, blue, this combination is given in the correct order. Question number 28 answer is first one. Question number 28 answer is first one, the correct order. Right? You have to remember the colors in the visible light region and how they vary. We have discussed about the electromagnetic spectrum now. Right. Let's go for the question number 29. Question number 29 is also something similar to this one. The color imparted on the Bunsen flame by metal atoms from the energy released from the release energy when the electrons return to the ground state. From the first principle, from the first excited state, the flame colors of some atoms are given below. Right, that means actually they have used some atoms, and they have used the Bunsen flame. And I remember the flame test, right? So electrons are moving from high energy level to a low energy level, and they are releasing some energy. So they're asking what is the correct order of the energy gap E1 and E0 for the atoms. So that means they're asking energy gap is greater in which element. That means frequency is greater in which element, right? So what are the colors they have given? Lithium, copper, sodium, potassium. These are the elements and their colors are also given. Look at this one. The elements they have given: lithium, copper, sodium, potassium. Lithium color is red, copper color is green, sodium color is yellow, potassium is violet. So these are the four colors they have given. They are asking what is the corresponding energy between the energy levels from n equal 1 to n equal 0. We cannot say n equal 0, but this is the high energy level. From high energy level to low energy level, electron is falling. Then the corresponding energy gap is E1 minus E0. We know that this is directly proportional to the frequency. When frequency increases, energy gap is also greater. Among these four colors, tell me students, which one has the greatest frequency or the greatest energy? Violet color. Therefore, the potassium has the greatest energy. Then we can say green color, because green color has the next one. Then yellow color, sodium. Then we have lithium. So this is the way that correct variation is obtained. Potassium, copper, sodium, lithium is given in fourth answer. Question number 29, answer is fourth one. Right? See how they have given the applications of the emission spectrum, right? Right, okay. Now let's go for the next question. Which of the following statement is not true? Bohr theory is a nuclear model of the atom. No. Bohr theory is actually energy level model, right? Not the nuclear model. Rutherford proposed the first nuclear model of the atom. Correct, ne? Yes, Rutherford is the guy who represented the first nuclear model. Electrons do not behave as waves and properties at one and the same time. Remember, students, according to the de Broglie's equation, we know that lambda equal h over mv, right? So, since we are applying this equation for the electron, this equation is representing the wave property of the electron as well as the particle property. So, can't the electron act as a wave and particle at the same time? So, according to this equation, that's possible. So, therefore, we can consider that is they have given what they have given. Electrons do not behave as waves and particles at one and the same time. Wrong. They can behave. E over m ratio of the cathode rays varies with the gas inside the cathode ray. Is that correct? E over m ratio of cathode rays varies with the gas inside the, that is also wrong. So therefore here the only correct answer is B. So question number 30 answer is 5 because only B is correct. Huh? Only B is correct. Look at the question number 31. The atomic spectrum of hydrogen is a line spectrum. Yeah. Under the spectrum analysis, I told you students, there are two types of spectrums. The first one is continuous spectrum. The other one is discontinuous or line spectrum or discrete spectrum. So continuous spectrum, for example, we can take that visible light region is a continuous spectrum. And complete electromagnetic spectrum series is continuous spectrum. Okay. And line spectrum, when you consider the atomic spectrums like hydrogen emission spectrum, right, and the atomic spectrums of other elements, they are actually discontinuous, right? They are releasing some energy and some of the energy radiations are absorbed, right? So when they are absorbing some of the energy radiations, they are releasing some. So therefore, those are actually discontinuous spectrum. Yeah, atomic spectrum is a line spectrum which is discontinuous. The energy associated with each line of the spectrum is equal to the energy of the electronic levels corresponding to the line. Wrong. Spectral line is not representing the energy of the corresponding energy level. Wrong. Spectral line is representing the energy gap between two energy levels corresponding to the electron transition. Right? Just now I explained this one. So therefore wrong. 31 answer is third one. Question number 31 answer is third one. Right. Question number 32. Which of the following statement is are true? Positive rays are formed when an electron is removed from a gas. Correct that one, students. Positive rays are formed when an electron is removed from a gas in cathode ray tube. Correct that statement. Positive rays are formed when an electron is removed from a gas in cathode ray tube. Yeah, that's correct. Normally electrons are removed, then only positive rays are formed. Cathode rays originated from the cathode. Correct, that's also correct. Positive rays originate from the anode. Is that correct? Can you remember we learned that anode rays are actually forming at the mid of the cathode ray tube, right? In the path, right? Can you remember the diagram that we discussed? When we consider the here inside, in here we have the perforated cathode and here we have the anode. Negatively charged one, positively charged one. So when we inject hydrogen molecules, what will happen is hydrogen is forming H plus and electrons, H plus electrons, H plus electrons. So the electrons are actually traveling towards the positively charged one. H plus is actually moving towards the cathode. So these are the protons, right? So these protons actually originated at the middle of the cathode ray tube. So therefore, that is wrong. Cathode rays are a type of electromagnetic radiation. Did we discuss cathode rays electromagnetic spectrum? Is containing electromagnetic spectrum? No. Electromagnetic radiations are, we can start from PV radio and radar. Then we have what? Microwaves, infrared, visible light, ultraviolet, X-ray, gamma. So those are the radiations containing in the electromagnetic spectrum. So therefore, that is wrong. Question number 32 answer is first one. Let's go for the question number 33. Which of the following pairs of lines has the difference between them which is equal to the uh, third and fourth lines of the Lyman series of each spectrum of hydrogen? Right. I think when we draw the energy level diagram, we can go for the answer for this question easily. Let me draw the diagram. Right. Okay. In this way. Uh, which of the following pairs of the lines have a difference between them which is equal to the equal to that between third and fourth lines of the Lyman? So which is the third one and fourth line? 1, 2, 3, 4, 5. So third and fourth one is this one in Lyman. That means if you consider a gap, this is the gap. Okay. So when you go for the Balmer series, which gap is represented by that? Same gap is actually between second one and third one in the Balmer series. When you go for the partition, in partition, first line and the second line. First and second is the gap, right? So that means we can tell that in Lyman series, third and fourth gap, lines gap is equal to Balmer series, second and third gap. Then when you consider partition series, first and second gap. Okay. Then we can say that the correct answer is given in third and fourth lines in the Balmer series wrong. First and second line in the partition series correct. Second and third in Balmer correct. So therefore the correct answer is B and C. Question number 33 answer is 2. Option B and C. Right. Right. Question number 34. Electron behaves sometimes as particles and sometimes as waves. Wrong. They can behave both particles and waves at the same time. Electrons have both particle and wave properties. That's correct. So therefore, question number 34. First statement is wrong. Second one is correct. Therefore, answer is number 4. A sample of hydrogen atoms excited in a flame has electron distributed in 1, 2, 3, 4, 5 energy levels. How many different wavelengths of radiations are emitted by the sample according to the Bohr theory? Now here we have the diagram. So they are telling that 5 energy levels are there. N equal 1, and here n equal 2, n equal 3, n equal 4, n equal 5. So let me erase the sixth principal energy level. No need. Students, now count the electron transitions which are possible. Count the electron transitions. So we can remove the last one here. Now, how many electron transitions are there? 1, 2, 3, 4. Here we have 4 lines, 4 wavelength. Here we have 3. Here we have 2. Here 1. So therefore, 7, 9, 10. There are 10 different electron transitions, 10 different wavelengths. So question number 35 answer is. Question number 36. A part of emission spectrum of hydrogen is given below. Increasing wavelength is for this direction, right? Then what is the corresponding energy level diagram? So they have given here a spectral line diagram and expecting the correct energy level diagram that they have. So this kind of a diagram is given. So the lambda is increasing for this direction. Then we can say that the energy level diagram in this way. So this kind of a diagram can be seen in approximately third one, right? So but there is actually an issue with the gaps, but according to the answers that they have given, we can choose the third one as the option, right? So therefore, question number 36 answer third one. Question number 37. Which of the following statement are true regarding positive rays which have been detected during experiments with discharge tube in determining atomic structure? They are found together with cathode rays are responsible for the glow observed in the region behind the perforated cathode. Yes, correct. Right? Normally in the cathode ray tube, when we are doing the experiment, for example, with hydrogen gas, behind the anode, we can see the green color glow because of the cathode rays. Behind the perforated cathode, we can see a red color glow because of the positive rays. So that's correct. They are formed by loss of electrons from atoms and molecules. Correct. They consist of particles whose mass is independent of the residual gas. What do you think? They consist of particles. So these are actually positive rays, no? Whose mass is independent of the residual gas. What do you think? They consist of particles whose mass is independent. Is that independent or dependent? Just imagine we are using hydrogen gas, we have H plus. If we are using helium plus, helium gas, we have helium plus. That means the mass of that positive particle is depending on the gas that we are applying. So therefore, that is not correct. They are not affected by electric. That's also wrong. So therefore, question number 37 answer is number 1. right? Read the statements carefully. Yeah. Right. Okay. Question number 38 is a calculation. Let's do that one quickly. Question number 38. The energy of 1 mole of photons of wavelength is 305 nanometers. They're asking the energy of 1 mole of photon. Remember, students, we know that in order to calculate the energy of just one photon, we can use E equal hc over lambda. But when you're finding the energy of a photon mole, you have to multiply this one by Avogadro number. Then let's find out 6.626. So here they have given 6.62. 10 to the power minus 34 joule second, and velocity of light 3 into 10 to the power 8 meters per second. Avogadro number 6.022. 10 to the power 23. Lambda 305. That means 3.05 10 to the power minus 7 meters. Meters cancel off. Second per second cancel off. Then we have E moles is equal to. We know that Avogadro and Planck's constant multiplication. This is 39.9, right? That means we can take approximately 40. And here, we can't take like that. They are expecting the correct decimal value. So therefore, we have to do the simplification. 6.62, 6.022 multiplied by 3 divided by 3.05. Then 10 to the power minus 19 minus 4 kilojoules per mole. Right? Then we can have 6.626, 6.022 10 to the power 3 divided by 3.05. We can give 10 to someone here. Let me give that one to 60.22 kilojoules per mole. Right. Let's do the calculation. What is the log value? Log value for 3 is 4771. Avogadro is 7797. Planck's is 8213, right? Summation. Three 35. 35 means 4843. 9 here, 5, 2. 2.5938. 5938 antilog 39.25. So this answer is given in which option? Yeah, approximately the correct answer is third one. Question number 38, answer is third one. So these are calculations, okay? We did the calculations of electromagnetic radiations. Right, okay. Okay. Question number 39 and 40 are based on the following paragraph. Read the paragraph carefully and select the answers for the questions. Right? Actually, reading this paragraph is not that much compulsory, but let's see, we can learn something about, I think, photochemical chemistry and everything. Yeah. Yeah, when light strikes on the certain metal surface, electrons can be ejected from it. The energy carried by the photons in light is transferred to electrons in the metal. And if an electron acquires sufficient energy to overcome its attractive force with a positively charged nucleus, it may escape from the surface as a photoelectron. So this is actually known as photoelectron effect. Okay? The minimum energy required for the electron to escape varies from one metal to another, right? Question: the energy required for the photoelectrons to be ejected from the surface of barium is 240 kilojoules per mole. 240 kilojoules per mole, the minimum frequency of light capable of producing a photoelectron in barium is. Look at that, all the values are numerical whole numbers, right? 6, 5, 2, and 10 to the power values. So therefore, we can do the round of values and go for the answers. So again, here also, we have to use energy expression equal Hc over lambda. Let's see. We can say that equal Hc over lambda. Instead of C over lambda, H nu capital L. Then mu equal E over HL. What is the energy they have given? 240 kilojoules per mole. 10 to the power 3 joules per mole. Planck's constant. Avogadro 6.022 10 to the power 20. First of all, deal with the units. Per mole cancel off. Joule will cancel off. So frequency is obtained by per second. No. Then here we know that 6.626 multiplied by 6.022, that is equal to 39.9. But I'm taking here, this is as 40 for our simplification. 10 to the power minus 34, 23 means 1 minus 11. 1 here, 60. So therefore, nu equal 10 to the power minus 10 to the power plus 15 per second, 4 hertz. Have they given this answer? Here answer is 6, so therefore 14. Yes. Frequency is 6 into 10 to the power 14, right? Yeah, in some MCQs, we can take that this product 6.626 multiplied by 6.022 is equal to 39.9. Approximately, this is equal to 40. We can take like that. Okay. Then here answer, we can take that 39. Answer is fourth one. Now let's go for the 40th question. In the 40th question, they're asking the maximum wavelength of the light that can produce this effect in barium. Let's see. Right. So do the calculations correctly. Huh? It's very, very important. right? So how do you find out the wavelength? We can find out the wavelength in this way. C equal nu lambda. Lambda is equal to C over nu. Velocity of light 3 into 10 to the power 8 meters per second. And the frequency is 6 into 10 to the power 14 per second. Per second will cancel off 1 here 2. So therefore 0.5, 10 to the power minus 6 meters. That means 5 into 10 to the power minus 7 meters. We can say that 500 nanometers. Is that the answer? Question number 40. Uh, 500 nanometers. Forty answer is third one. Okay. Question number 41. Quantum numbers. Right. Okay. Can you remember quantum numbers theories we learned? Quantum number theories. In the quantum numbers, I told you that there are 4 types of quantum numbers. Right. So what are they? N, L, ML, MS. So these are the symbols that we are using. N is the principal quantum number, which is representing the principal energy level, right? So it can have the values like 1, 2, 3 up to infinity. We can have the values. Then L is actually sub-energy levels, magnetic azimuthal quantum number or angular momentum quantum number, representing sub-energy level. For the sub-energy level, we are assigning 0. L is 1. Sorry. P is 1. D is 2. F is 3. Likewise, we have the quantum numbers, azimuthal quantum number for the energy, sub-energy levels in this way. Then we have magnetic quantum number. When you consider a sub-energy level, we have only 0. When you consider P sub-energy level, since there are 3 P orbitals, minus 1, 0, plus 1. For the D sub-energy level, minus 2, minus 1, 0, plus 1, plus 2. For the F sub-energy level, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Likewise, we have magnetic quantum numbers. And then for the spin quantum number in an orbital, we know that there are 2 electrons. One can has plus half and the other one has minus half. So these are the quantum numbers actually we learn as a theory. Now go for the question. The number of atomic models, atomic orbitals possible for which the quantum numbers n equal 3 and ml equal minus half. Okay. N equal 3 and ml equal minus half atomic orbitals. Look at this one. Look. N equal 3 and ml equal minus half, minus 1. N equal 3 means, students, we know that third principal energy level containing 3 sub-energy levels, S, P, and D. And ml equal minus 1. We know that in S orbital, we have 1 orbital P. And in D, actually, we have 5 orbitals. No? How we can assigning the magnetic quantum numbers? ML means magnetic. Here minus 1, 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. So therefore, there are 2 atomic orbitals which can represent the minus 1 magnetic quantum number. So therefore, orbitals are 2. Question number 41, answer is second. Question number 41, answer is 2. Right. Question number 42. All the molecules end up at n equal 1 for the Balmer series in the emission hydrogen spectrum. Is that correct? Balmer series means all the electron transitions possible to the second principal energy level, not for the first principal energy level. So therefore, first statement is wrong. The Bohr model is used to explain the origin of the hydrogen spectrum. Yeah, that's correct. So therefore, question number 42, answer is fourth one. 42, answer is fourth one. right? Then the next one, question number 43. Which of the following statement is are true with regard to the electromagnetic radiation of wavelength 200 nanometers? So if the wavelength is 200 nanometers, which statement is correct? Look at that first one. It has a higher frequency than the radiation of wavelength 400 nanometers. Remember, students, when you compare the wavelength and frequency, wavelength is 200 nanometers here, 400 nanometers here. So which one has the greatest value of the frequency? This one has the greatest frequency and this one has the lowest frequency, right? So therefore this is high frequency and this is low frequency, right? Very simple comparison. It has a high frequency than the radiation of wavelength 400 nanometers, correct. It is the visible region of the electromagnetic spectrum. Is that correct? Visible region is actually about 390 to 720 again. So what is the region that I gave you? Can you remember that one? What is the visible light, electromagnetic spectrum, visible light region, wavelength region that I gave you? That is about, yeah, 752 or 380. So therefore, this is actually not belongs to visible light region. We can't take that. In a vacuum, it has a higher velocity than the radiation of wavelength 400 nanometers. That is wrong. So if there is actually electromagnetic radiation in vacuum, they have the same velocity. Its proton has a higher energy. Its photon has a higher energy than a photon radiation of wavelength 100 nanometers. What do you think? Its photon, look at this one. Its photon has a higher energy than a photon radiation of wavelength 100 nanometers. We know that if we include the energy here with 100 nanometers here, we can tell that 100 nanometers, right? When you compare the energy, which one has the greatest energy? The greatest energy should belong to 100 nanometers. Why? The reason is lambda and the energy, they are inversely proportional, equal hc over lambda. Energy is inversely proportional to the wavelength. Therefore, when the wavelength is lesser, energy is greater. When the wavelength is greater, energy is low, right? Then we can say that that statement is also wrong. Its photon has a higher energy than a photon of radiation wavelength 100 nanometers wrong. So question number 43, answer is number 5. Right? 43 answer is number 5. Right, okay. Shall we move to the next question? Question number 44. Which of the following statement is true for an electron that has the quantum numbers n equal 3 and ml equal minus 2? Right. So remember students, n equal 3 and ml equal minus 2. So where you can see that third principal energy level, magnetic quantum number minus 2, this orbital, only this orbital. That means this is actually 3D orbital. Right. Let's see what other statement they have given. The electron is in the third main energy level, correct? Third principal energy level. This electron is in d orbital. Yes, that is d sub energy level, d orbital. The electron is in p orbital. Wrong. That is wrong. The electron must have a spin quantum number ms equal plus half. Actually, they cannot give must have plus half. It can be plus half, right? We cannot compulsorily, that means we cannot put the term must there, right? Because it can be the plus half or minus half. So that statement is wrong. So question number 44, answer is A and B statement correct. Therefore, number 1. Right. Question number 45 is a calculation. Let's do that calculation quickly. A lamp produces 6 joules of energy per second in the blue region of the visible light. For how long should the lamp be lit to generate 1 into 10 to the power 2 photons? Right. Now look at this one, students. First of all, since they have given the wavelength 470 nanometers, let me find out the energy of a photon. 6.626 10 to the power minus 34 joules seconds. Velocity of light is 3 into 10 to the power 8 meters per second. Divided by lambda wavelength is 4.7, 10 to the power minus 7 meters. Meters will cancel off. Second per second will cancel off. Then the energy is equal to, we can say that 6.626 multiplied by 3 divided by 4.7, 10 to the power minus 19 joules. So this is the energy of a photon. Without simplifying, I'll keep this one. This is the energy of a photon, right? Carefully understand this question. This is the energy of a photon. Then they're asking, a lamp is producing 6 joules of energy per second, right? 6 joules of energy per second of the visible light. For how long should the lamp be lit to generate 1 into 10 to the power 20 photons? Students, you can say that if the lamp is actually producing 6 joules of energy per second, how much of photons can release by that lamp, right? How much of photons will contribute for this process within 1 second? How do you find out that one? Total energy is 6 joules, right? In order to find out the number of photons involved in this process, we can divide the total energy of the energy that we calculated for one photon. Then you will obtain the number of photons. 6.626 multiplied by 3 10 to the power minus 19 divided by 4.7. What is the total? The total energy should be 6, no? 6 joules. What is the energy of a photon? 6.626 into 3 10 to the power minus 19 joules divided by 4.7. So joules will cancel off here. 1, 2. 2 into 4.7 divided by 6.626 into 10 to the power minus 9. 10 to the power plus 9. So these are the number of photons, students. Can you understand? These are the number of photons that they have given. A lamp produces 6 joules of energy per second. These are the number of photons releasing that energy per second. Then Look at this one. We can take that photons and the time. This amount of photons releasing that energy within 1 second, right? So here we can say that this is 94, 9.4, 6.626, 10 to the power minus 19 photons. They are asking 1 into 10 to the power 20 photons will contribute for how much of time to lit that lamp. Then we have to find out that time. So that's all. Very easy. What we have done, first of all, we found the energy of a photon. And they have clearly mentioned in this question, the energy emitted by this lamp is 6 kilojoules. Then when you divide the total energy from the energy of just one photon, you will obtain the number of photons that totally emitted that energy from that lamp. These are the number of photons. Then this number of photons emitting that energy for 1 second. Then if we use 1 into 20 photons, how much time that will take? Now you can find out T is equal to, right? T is equal to, for 9.4 over 6.626, 10 to the power 19 photons, just 1 second is enough. Then for 1 into 10 to the power 20, how much time? 10 to the power minus 19 will cancel off. Here 1. Then we have 10 multiplied by 6.626 divided by 9.4 seconds, right? 66.26 divided by 9.4. What is the answer? Let me use logarithms. 8213. 94 log value is 9731. 2 here, 8. 11 means 4. 7 means 8. 0. 8482 antilog. 8482 antilog. 75. 75. 7.05 seconds. Do we have that kind of answer? Yes, 7.1. Question number 45. Answer is second. Right? Question number 45. Answer is second. Vidushana, yeah, we can do in that way also. Yeah, correct. We can have many methods to do a calculation. Okay. Your method is also correct. Quickly complete this calculation. Right. Okay. Let's move for the question number 46. Consider the following statements, number 1 and number 2. The energy absorbed or released by atoms is quantized. Who said that one? Quantized Max Planck. Small particles under appropriate conditions show wave properties, Louis de Broglie. Max Planck and Louis de Broglie. Question number 46, answer is second one. Question number 46, answer is second one. 47. Consider the following discoveries made with regard to the atomic structure. Positive rays inside a cathode ray tube. Positive rays found by Eugene Goldstein. Radioactivity, certain types of nuclei. Henry Becquerel. Eugene Goldstein and Henry Becquerel, they have given in number 5. Then question number 48. That's also a calculation. Let's see. The de Broglie wavelength of a neutron traveling with a velocity v. If the kinetic energy is E of the neutron, energy is, if the kinetic energy of this neutron is increased by 4 times, the new de Broglie wavelength would be. Right. So we have to do a calculation here as well. Students, can you remember we learned the de Broglie wavelength equation? Students, can you hear me now? Can you hear me now? Right, okay. Now you can see that this is actually de Broglie wavelength and the kinetic energy connection. So they have given for the neutron, the initial de Broglie wavelength is lambda h 2me square root of this one. And we can take that lambda dash, right? Lambda dash h over 2m multiplied by mass is not changing for the neutron, right? And here E means what? Kinetic energy. OE. Kinetic energy is increased by 4 times. And then lambda dash is equal to h over. I can take this 4 from the square root. I can take 4 out from the square root. Then it becomes 2me in this way. So h over square root of 2me is lambda. Then lambda dash is equal to lambda over 2. So the new de Broglie wavelength is lambda over 2. Question number 48, answer is first one. Right. Okay. Students, then we discuss almost half of the tutorial. I think today we discussed 88 MCQs. If you count the number of MCQs, 88. And we have a same number, sometimes greater than this one. In the next session, I'm going to conduct another session in next Saturday morning also. And I'm going to finish the tutorial, password tutorial that day. And Sunday night, next week Sunday, not this Sunday, next week Sunday, I'm going to conduct that unit test that I told you. Now you have some kind of practice of these MCQs now. So therefore, after the completion of the second session, I will conduct your exam. Exam means a unit test. Very simple examination. 50 MCQs will be there. Now you have some kind of idea about how to do the MCQs. So that is the way. Okay, right. So please raise your hand who understood the things that we discussed today. Are these things okay? Please quickly raise your hand. I believe that this session was useful for you all. Next Saturday also I'm going to conduct the remaining MCQs in the paper book, right? Okay. If you have any doubts, please send me a WhatsApp message again. I will explain you what happened in those questions. If you have any doubts, please send me. Okay. Right. Then this is the first session, end of the first session of the past paper discussion of Unit 1 Atomic Structure. Next Saturday morning, I will conduct the second session of this topic. Okay. Right. Okay. Then let's meet on the next session. Until then, bye bye. Have fun.